Hello children, hope you are doing well. Once again we are here to continue our topic chemical effects of electric current, and what today I am going to discuss is chemistry behind electrolytes, chemistry of anions, cations, and how electrolytes are going formed. So children, there are two types of electrolytes, strong electrolytes and weak electrolytes. One question: why some chemical compounds are known as strong electrolytes? The answer is they dissociate into positive and negative ions, means up to 100%. They completely dissociate into positive and negative ions. Right? So what may be the strong electrolyte? Strong electrolytes are strong acids, strong bases, and strong salts. Once again I am reminding you, what are strong electrolytes? Strong acids, strong bases, and strong salts. Let us see some examples. Dissociation into ions up to 100%. Strong acids, hydrochloric acid, sulfuric acid, nitric acid. Strong bases. Examples are sodium hydroxide, calcium hydroxide, etc. And children, what are the examples of strong salts? Again we have sodium chloride, potassium chloride, calcium chloride. So children, we are getting here examples of strong electrolytes, which are strong acids, strong bases, and strong salts. They dissociate into ions completely, positive ions and negative ions. Now children, we have to see what are the examples of weak electrolytes. Weak acids, weak bases. So children, what I was telling you, example of weak acids are organic acids, carbonic acid, acetic acid, phosphoric acid. So all these comes under weak acid. In the same time, example of weak bases are ammonia, ferric hydroxide, FeOH3, and aluminum hydroxide. So all these are examples of weak electrolytes. Why they are called weak electrolytes? Just because they partially dissociate into positive and negative ions when they are dissolved in water and current is passed through them. And we have already seen what the strong electrolyte is. Strong acids, strong bases, strong salts. Right? We will discuss chemistry of ions. What are some important core ions? In form of core ions, we have nitrate, carbonate, sulfate, and phosphate, represented by NO3 and one negative charge over it, carbonate, so in form of core ions, we have nitrate ion, carbonate ion, sulfate ion, and phosphate ion. And along with the chemical representation, chemical formula of ions, we are getting here. When we are adding hydrogen plus ion, means one cation, in this anion, it will change to So children, we are seeing here three types of ions: ides, aids, and ides. How to differentiate between them? By seeing their chemical composition. Carbonate, see the quantity of oxygen. We have to convert aids into ides. So for that, into ides, remove one oxygen. What we have to do? For converting aids into ides, we have to remove one oxygen and charge will be same. SO3 minus 2. Just see the change here. We have removed one oxygen and the charge is same. -2 here, -2 here also. The sulfate becomes sulfide. In this way, children, nitrate. Nitrate has become nitride. And in this manner, phosphate will become phosphide. 8 same ides are clear. Now we have to deal with ides. From ides to ides. Sulfide, nitride, so children, sulfide, see here changing. Sulfide charges 2 minus, nitride and 3 minus, and phosphide again we have P 3 minus. So look at the whiteboard. In the form of core ions, we have carbonate, sulfate, nitrate and phosphate along with the formula. How we are going to change A's into ides, sulfate into sulfides, nitrate into nitride, and from same A's, how we are going to change into ides, sulfide, nitride, and phosphide. Please stop. We have just seen the A's, ides, and ides of core elements. Now we will be discussing some halogen elements. I think you should be aware of that halogen elements. Okay. In our next lecture, when we will be dealing with periodic table, I will give you all the details there. So what are the halogen elements? Chlorine, bromine, iodine. When these elements, chlorine, bromine and iodine, forming an ion. So chlorine becomes chlorate, bromine becomes, and iodine becomes iodate. Formula for chlorate is ClO3 minus. Formula for bromate is chlorate, bromate, iodate. Just see here, have a look here, what I am going to do the next. We are adding plus oxygen O. So chlorate will convert to perchlorate. Bromate will convert to perbromate. And iodate will convert to just see the conversion. Chlorate to perchlorate, bromate to perchromate, and iodate to periodate. In our next step, children, we are going to remove one oxygen. See what happened. One oxygen is removed. what we are doing here? What we are doing here? Remove. Please focus here. Remove one oxygen minus O. First of all, chlorate will convert into chloride. Bromate will convert into bromide. Likewise, iodate will convert into from chloride, bromide and iodide. Again we have to remove one oxygen and it will convert into another anion. The name will be different just by removing one oxygen. See one similarity, children. What is the one similarity? See the charge. Charge is same. Here also by removing one oxygen it will convert to chloride, bromide and iodide. Again we are going to remove one oxygen. Just see what happens. Again minus O and the result is charge remains same. It will convert to hypochlorite, hypobromite, and hypoiodite. Children, this time we are going to study formation of anion by halogen elements, also known as noble elements, chlorine, bromine, iodine. From here to chlorate, bromate, iodate, perchlorate, perbromate, periodate, and you are seeing like this. Please stop. So children, while solving numerical problems, you will also see some other important ions. You have to work with it. Hydroxide ion, cyanide ion, acetate ion, permanganate ion, and dichromate ion. Hydroxide ion, OH minus, cyanide ion. Just have a look at the whiteboard. We have hydroxide ion, cyanide ion, acetate ion, permanganate ion, dichromate ion with their formulas. Children, all these anions, what are these anions? Forming from anions from non-metals. Anions from non-metals. And always remember children, in the list of non-metal anions, we have one element, ammonium ion, forming with the help of nitrogen and hydrogen. This ammonium ion is the only common cation forming from non-metal. Non-metal usually forms anions, but ammonium is the only non-metal but cation. So children, please have a summary of today's lecture. Today, we have dealt with what are the strong electrolytes, what are the weak electrolytes, why they are known as strong electrolytes and weak electrolytes. After that, we have studied some non-metals and how anion radicals are going to form from them and what are their formulas. How we have to form X, I's and I's. We have also seen halogen elements and all the anions, important anions. In our next class, children, we will deal with cations, and the cations form from metal. Thank you.